So, thank you all for coming to my talk. I'm John McIntosh, and I think it's probably been about 10 years since I was here last to give a conversation. Um, I brought reading glasses this go around, but I didn't have 10 years ago. Um, I came in probably and talked about Squeak on iOS, which then turned into Scratch on the iPad. And actually, there's a gentleman in the audience who was part of the forking of that product and then the distribution in the Japanese App Store. And I believe there's actually been over 1 million downloads of that into the Scratch community. So today I'm going to just cover LabWare's work on MQTT and talk a little bit about why we picked this technology. What happened is that a year and a half ago, when over the last 3 years, busy developing LabWare Mobile, but a year and a half ago, we had to look at how to do communications from a phone to a cloud server, and we couldn't use HTTP, HTTPS. We need to use WebSockets, and so a young lad that I worked with by the name of Kurt. Kurt is also one of the world experts in Scarlet Smalltalk. He now actually works for Gemstone. So the Gemstone people tell me they're so proud to have an expert Scarlet Smalltalk engineer on staff now. So really the questions were what and where and why and power and traffic and response. And but before I really get into that, I have kind of a communal slide to show. We're looking for help to save Sophie. And this is a product that Tim Rolich, Michael Ruger, and myself worked on for 5 years. And it was really a book publishing animation system. And so today, I have kind of regret that the Smalltalk community isn't using Sophie to present all their slides. We're using PowerPoint or Keynote or something like that. So after the show, when we do projects we're working on, people can come ask me and I'll show some Sophie books. This was driven a few days ago when there were people looking for guidance on how to do things in Cairo in terms of text layout and so forth. But we did all of that in Sophie to match requirements from the publishing industry. So on to MQTT. And yesterday I actually had a product with 1 T in it, but today I have a product with 2 T's in it. So the T and the T stands for telemetric transport. And the MQ stands for MQ, an IBM product. And so MQTT came out of work in the late 90s from IBM, really to provide a way to move data from SCADA systems using low power and dealing with unstable networks. The presenter this morning that she talked about remote procedure calls, and of course there was the laws about the network is, has no overhead and it's free and it works all the time and life is wonderful, and those are all not true. So really what happens here, you have a sensor, it publishes to a topic. You have device 1 and 2, which at some time in the past or in the future have subscribed to topic Y, which is interesting because the broker actually can act as a persistent store. And so then what can happen is that it can store data so that device 2 later can wake up, but it will get those messages. The other interesting thing here is the quality of service option. And so I've actually found this is interesting from a development viewpoint, because you can choose to say you want data thrown at someone and you don't really care if it ever arrives there. Uh, Interesting enough, when you restart a broker, if the data it sees is in a quality of service 0, it just throws it away because the contract obligation is that it doesn't ever need to be persisted to present later. Quality 1 is that the data is delivered at least once, but it may be duplicated. And then there's a quality 2, which is a double handshake that guarantees the data is delivered once and exactly once to the receiver. And so the interesting thing about this is that type of contractual agreement is in the communications layer. It's not in your application layer. So the other things that we looked at was we were concerned our most of our client base may be out in the field collecting data remotely, such as doing water sampling in chemical plants, taking readings and samples and stuff like that. So they're running, battery life is a particular consideration. And when I looked into this, there was some student here, I think in Europe, that did a study on terms of how does MQTT versus HTTP affect power consumption on an Android phone. And also they tested against 3G and Wi-Fi. And these are the things they came up with, that it was 22% more energy efficient and 15% faster. And so to us, that was like a benefit because of these are all kind of good things. And then we found out that it's actually the transport layer for Facebook apps. So when we were then looking, we had to use an existing library on the phone. So we just forked the public fork of the Facebook libraries. It was a little more complicated for for Android, because we couldn't find, I think, a library that was mature enough, and we had to do some work to make it work. The current version of MQTT is 5. That's probably our winter 2020 work to bring our base up to that. And the other interesting thing is that the spec for the document is about 50 pages. It's not like 100 or 200 pages, so it's quite, I was going to use the word easy to tackle, but of course that's not quite true. But in any case, it's not an insurmountable problem to go through the spec and confirm what you have or what you're building is reality. And we did find a bug in the spec, actually. We wrote, and they officially did a rev change in order to fix the spec bug. So what I did is I took Tim Rollage's work. He did an MQTT client for Scratch on the Pi computer. And that's the original link to that from the Squeak source. I did feed fixes back to Tim. And for people who know Tim, was very British. I would get British mumbling about when I sent patch requests back to Tim. So the other interesting thing is that we needed a data broker. The problem LabWare had is that if we were to introduce a commercial broker into the environment, that triggers basically a verification and validation step by the IT department in the organization. And that can be a very long process or require lots of paperwork and justification. But we got sneaky because, in fact, actually, in a VSE image, we can introduce all this new behavior in an SLL. And then it's just a software patch, which is an agreed, viable thing to do to the installation. So we then set out to take Tim's code, refactor it, and then actually create the data broker. And I had actually worked 5 years with Tim on Sophie, so I was quite comfortable with his style and his coding practices. And he had there was only kind of minor changes to and sharing of code between the client and the data broker. There's a heavy overlap in terms of how uh, MQTT records are used from the broker viewpoint versus the client viewpoint. Um, and of course, actually, we had to make the client for Scarlet Smalltalk, but we also had to make a client glue code for Swift and Java, and that was because we we didn't want to write all the code in pure Scarlet Smalltalk on the platform when there was existing mature code that's native to the platform. And so there is a Pharaoh version at that particular GitHub address. What I did for that is we took the VSE version, and the only two places I had to change in our code base was the method isn't related to a listener. For the data broker, it has to open up an MQTT. Yes, an MQTT socket, protocol socket, and then we need to actually interface with a socket stream. And so, of course, since the socket stream, we actually took for VSE the Squeak socket stream logic, but it's quite compatible. It's compatible to what is actually existing in Pharaoh. So once we had actually created the Pharaoh socket stream, it just worked. So this is just an example of the spec document, and we took it in a spreadsheet, and then we added bolding where these are methods and classes that we created. It's a bit tedious. It took a few months to go through. We had some interesting issues with timeouts and concurrency and so forth. So it just took time, but it was not a difficult task to do. In terms of testing, someone asked me about where the test scripts are. What we found is actually because you're a service, you're either an MQTT client or you're an MQTT broker, then other people like IBM have compliance test suites for the standard. And so then we just ran the compliance test suites, and we got to the point where all the compliance test scripts ran, and then we could say that we were a V311 compliant product. And if you're looking for test data, well, testmosquito.org will send you 24 gigabytes of data a day, probably more now. It was really funny because when you looked at what was going through there, you could see people have written apps for the App Store, and they need a data broker, but they don't want to pay anyone anything, and so they just use, the mosquito.org test server. So, and send pictures and all sorts of things through it. It's interesting people's view of privacy. So there was a lot of work. If you had asked me how long will this take, I would have probably said, a month or two or something. But it obviously was not a full-time job, but it did actually take a fair amount of time. And at the end, what happened is that Kurt said, that's great, but that's way too complicated for most people. So what we need to do is a one-to-one simplified relationship. And we'll call it an endpoint. And here's like a couple of sentences scrawled in the back of a napkin, and go away and implement it. So what it is all about is hiding complexity. So we really have the datum, which is the data, a tag, and a target. The data is opaque, and we really said the data is opaque. And I learned this morning the data could actually be like this hand grenade. I'm sorry, you didn't use hand grenades, swords, I believe. But it was like, don't touch the data, don't put metadata in the data, don't unwrap, rewrap the data. Everything should be in the tag. So on the basis of this, we created this tag that is somewhat like there's a session identifier, target endpoint, the receiver endpoint, which usually is me, the command that you want to issue, whether that's sync or async or async with response, and then the endpoint service that you want to talk to, and the tag that's used, and then actually a promise ID, which we'll talk about in a sec. So in this case, it would be, this topic is private to a particular user. It's targeting a particular device. And when the message arrives, then it looks up the endpoint service and executes the tag and the data. We do a perform, basically. And if there is a response type of command given, then we return the data that we received from the perform. So it really came down to that there was three types of sends that we wanted to do: send sync, and send async response. But in order to do the send sync, we needed to have a promise class. And so the other part in here was actually we have the receive, which incoming data, and there's also a receive error. So the error, a receive error can be actually an asynchronous future event that happens if the software as a service throws an error back at you later, we would receive it. And then, of course, typical Smalltalk fashion, handle it. So when we looked at promise, there was lots of self-doubt and pain and failures, because what we needed to do was halt the JavaScript thread, get data to the MQTT network thread, get data back, signal and restart the JavaScript thread. And while this did not work very well, there is actually this JavaScript promise. The promise didn't actually solve the issue for us. It sounded good, but we could never get it to work the way that we wanted. And ultimately, one morning, I realized that we really needed to share the promise logic between the JavaScript and the platform. So what happens is we now stop the JavaScript thread via the platform semaphore, examine incoming publish tags for the promise fulfillment. And if you recall earlier in the slide I had where I had a promise ID, well, that is the chunk of data we need to say, hey, if I get this message in, I'm fulfilling a promise, so I need to then fulfill that on the platform side, signal the semaphore, and then the JavaScript wakes up, and then it actually does a value against the Scarlet Smalltalk promise, which then actually fetches the promise data from the platform interface. Or, of course, and the promise is actually an object that comes back, and it either has data or it has or it's an exception. And so then either we return the data or we actually take this metadata for the error, and we then build a Smalltalk exception and throw it and hope that someone is going to catch it. So the Scarlet Smalltalk code for this, it's just a primitive call, right? So we just say, wait for so many milliseconds. We had to do that. It's a question of, the other fun question is, well, how long do you wait for? Forever, or 8 minutes, or 12 seconds? What if I'm going to sell your connection and I'm pushing a megabyte of data that's going to take like 46 seconds to transmit the data before it actually gets to the other side? So you have to calculate or guess or estimate what is it, a rational timeout value. And so in Scarlet, then this is the actual JavaScript stub. You can see how we do validation checking. We look at object, we look at data perhaps, and then we actually do this handler, wait for timeout. The interesting thing here is that this native handler is actually an instance variable in the JavaScript object that points to the Swift guy, and then the Swift guy has a back pointer, so they both point to each other. And we use something called model view model to help us with concurrency problems between the JavaScript environment, which is single-threaded, and then the platform side, which is highly multi-threaded. And you can see here actually what we do is if the return value is nil, that's unacceptable, so there's a prim fail. And then we actually go and look at the return value, and we actually, in this case, we're actually creating a Scarlet Smalltalk byte array with the contents of a uint array. And the reason we did this here, we could have actually done this kind of thing in Swift, but we decided that we didn't want to directly create complex objects in the Swift code, that it really needed to be the responsibility of the JavaScript glue code, because then it's easy to go change the glue code, because it's technically a text file that's loaded when the JavaScript thread is started and initialized. So over on the Swift side, there's these nasty bits that when you allocate memory for JavaScript objects, you have to do them on the right P thread because they enforce cross-thread memory access violations. And there's also interesting things about who owns the bloody object. So because we're creating it over an MQTT, a data buffer of say 20 megs, and then we're passing it in and turning it into a JavaScript object, and then it's also a Swift object, and then we pass it back up into JavaScript, and then what happens when it gets garbage collected, and who's gonna do, we're having garbage collection run on the object wrapper in JavaScript, but then we also ultimately need to run a Swift garbage collection to garbage collect the 20 meg buffer. So it sounds easy to do this, but then there's kind of all these gotchas and kind of, I'd say hassles that you have to go through. We actually realized that you can pass large objects from Swift all the way up into JavaScript without having them copied. But over on Android, we actually discovered that it would copy them byte by byte. And that was a huge problem to call an interface 10 million times. So it turned out that React Native used Apple's JavaScript core engine for Android. It took a week for us to find who the GitHub people were that made the official build. And then we basically forked that and worked with some other people. We found out we're the only people that were like trying to pass like 20 megs across the boundary. No one else does that. They pass little bits of data, not 20 megs of data. And actually, we are looking to fork and make that work available to the public. So the set and sync look like this. You come in, you make the promise with the transaction number. We have a topic thing. We make the topic with metadata, and then we do publish. And then we do wait on the promise. And then ultimately, we get data back. We decode the topic. We check to see if there's an error, and then we return the bytes. And that actually all fits in a method. On the other side, stuff that comes in, when you do a subscribe to block. And so that's a subscribe topic do block. And this is the block. And this is the block that we use. The only thing that's different You can see there's a topic, the message, and the quality of service. And we come in, deconstruct the topic, we figure out what our endpoint is, and then we do a perform with the data and the tag. And then that is actually the business logic at this point that runs. There's we have endpoint as an abstract class, and then the developers then can subclass endpoint and add specific behavior for a type of group functionality. So for example, we have an endpoint for like file transfer as an example. And then of course, actually, once the perform is done, there's some decision work about whether or not we need to return a response or we need to throw an error or something like that. So the non-obvious things is that, actually, I think I need to show this slide first. The architecturally, it kind of looks like this, where the LIMS client is either on the desktop here to my left, or it's software as a service, or it's a mobile user. You can see the mobile user over there on the right. It talks WebSocket, secure protocol to a DMZ zone, where we actually do the WebSocket, secure WebSocket to MQTT protocol. And then we would then actually do there's a HTTP request or an MQTT request that's sent to the MQTT data broker, which then sends it to, user 492 over on the left side. So the non-obvious things from this diagram are that we can actually have a LIMS SAS user like print to a local Bluetooth or TCP printer that's inside their firewall, yet it's visible to the phone, and so the phone can actually act as a proxy. Or we can have actually a LIMS appliance do the same type of thing. We can also send messages directly from one device to another device. The other interesting thing about the transport protocol, there's a ping and a pong offering that you can use. You can turn that off, but we use that actually to find zombie phones. So the rule is if you ping the phone 3 times, actually it's if you ping like the MQTT client from the server 3 times and it doesn't pong back once, then you're allowed to drop the connection. So that makes those zombie phones go away. MQTT also offers the reconnect, and if you're running in persistent mode, then of course it allows you to basically have data that's in flight still actually go to the end receiver. And that actually, the whole guaranteed message delivery is an interesting problem because the developers still think that they have an obligation to manage the delivery of the message, or that they're breaking messages across data commit across multiple messages, and they're doing stuff like restarting to resend the message. So there's actually some training that has to happen so that they understand that the network actually is helping them get the message delivery. The other thing that I thought just to end up with is that the danger here is that it's all in Smalltalk. And so at 1 or 2 points when I start up the data broker, I'm thinking, if I just introduce this like little application change here, a little application behavior, that would make life so much easier because it's just so easy to go deviate from the standard to meet some requirement of the application domain. So do I have any questions? Well, there's no questions. That's a first. Oh.
Did you measure the performance against HTTP after implementation?
No, we did not. We did not measure the performance. We basically took the paper that was written and decided. Some student was doing this, I think, for his master's degree. Then I think some prof signed off on it, right? So then it must be good. Thanks, Bruce.